Who is in charge? It's the foundational question of all our human systems. When a project succeeds, we put one face on the cover of a magazine. When it fails, our first instinct is to find the single person to blame. We are obsessed with central control. We build our teams, our companies, and our management hierarchies around this single idea. A single, authoritative hub. A project manager, a C-suite executive, a visionary leader. The master brain. We fundamentally believe that to solve complex problems, we must build an even more complex, centralized decider. This is the central control illusion. And it is the single biggest reason why our most important systems, our projects, our logistics, our strategies are so brittle. Think about it. That massive, top-down project plan that shatters the moment one assumption is wrong. The information bottleneck, where one busy manager holds up an entire team. The rigid hierarchy that can't adapt to a sudden market shift. These aren't features of a robust system. They are symptoms of a critical design flaw. We have mistaken complication for complexity. And we are paying the price. But what if there's another way? This brings us to the swarm. When we look at an ant colony, 1 million individuals moving as one, our human brain asks that same flawed question. Where is the general? Who is giving the orders? We are so desperate to find the master brain that we invent one where it doesn't exist. This is the swarm intelligence fallacy. We see a single, collective genius. But the truth is far more radical. The genius of the superorganism is not a single, giant mind. It is the absence of one. The solution to our most complex problems isn't a bigger, better brain. It's a radically simpler set of rules. Let's start with the queen. Our human bias for hierarchy makes us see her as a CEO. We project our organizational charts onto the hive, imagining her giving commands from a central office. This is fundamentally wrong. The queen is not a ruler. She is a reproductive engine. She has one job: lay eggs. She gives 0 orders. She has no strategic plan. In fact, she is a slave to the colony's needs. So, if the queen isn't in charge, who is? No one. There are no managers. There are no memos. There are no status update meetings. The colony, a system that can build living bridges, wage war, and run complex agriculture, operates with no leadership at all. The entire intelligence of the colony is bottom-up. It is an emergent property. And it all runs on a handful of incredibly simple, local rules. So how do they find food? Imagine a new nest. There are 10 ozone ants and 0 information. They don't hold a strategy session. They don't assign scout teams A, B, and C. Zeros. They just go. This is the first rule. Rule number 1. In the absence of a signal, move randomly and explore your immediate surroundings. It looks like chaos. Thousands of ants pouring from the nest in all directions. But it's not chaos. It's a massively parallel search algorithm. Each ant is an independent sensor, maximizing the colony's chances of finding something. And then one ant gets lucky. 50 meters away, she finds a dead beetle. A massive protein score. She can't carry it back alone. She needs to recruit help. But she has no radio. She can't send an email. So, she doesn't try to talk to any other ant. She simply turns around, and on the long walk back to the nest, she does one simple thing. She periodically taps her abdomen to the ground, depositing a microscopic drop of chemical, a pheromone. This is the mechanism that debunks the swarm fallacy. The word for it is stigmergy. Stigmergy is a form of indirect communication, where an individual's action leaves a trace in the environment. And that trace guides the next individual's action. It's a signal left in the work itself. Think of it like a shared Google Doc. You don't have to tell your colleague what you wrote. They just open the document and see the work. The environment itself becomes the collaboration tool. The ant has left a signal. This brings us to the second, equally simple rule. Rule number 2. When you find a valuable resource, return to the nest, leaving a signal trail behind you. But one trail is weak. It's just one faint chemical path in a world of random noise. How does the colony know to follow it? It doesn't. Another ant, still operating under Rule 1, random exploration, crosses this new, faint pheromone trail. Its antennae detect the chemical, and its entire programming shifts instantly. The random search is over. Rule number 3. If you detect a signal, stop exploring and follow that signal to its source. That's it. The ant follows the trail to the beetle. It takes a piece, turns around, and on its way back to the nest. It follows rule number 2. It deposits its own layer of pheromone, reinforcing the exact same trail. This is the feedback loop. The trail is now twice as strong. This makes it twice as likely to be found by a third ant. Which makes it 3 times as strong, then 10 times, then 100. Within an hour, what began as a random discovery by one ant has become a superhighway. 1,000 ants are now marching in a perfect, orderly line, dismantling the beetle and carrying it home. This is emergence, a complex, highly intelligent, large-scale pattern. Created from 3 simple rules that not one single ant understands. No ant has a map. No ant knows where the food is. No ant has the big picture. They are all just following their local, 3-line of code programming. Explore. Signal. Follow. This system is brilliant. But it's even smarter than that. What if 2 ants find food at the same time? One finds that beetle. The other, farther away, finds a single sugar crystal. Both will lay a trail. But the trail to the beetle is shorter, and the food source is larger. This means the ants on that trail will make more trips, back and forth, in less time. More trips mean more pheromone. More pheromone means a louder signal. That trail will exponentially outcompete the weaker, less efficient sugar trail. The colony doesn't split its workforce. It automatically allocates the majority of its resources to the highest value, most efficient opportunity. With no project manager, with no quarterly review, with no central planner. The system is self-optimizing, and it's anti-fragile. What happens if you, a human, step on that superhighway? You wipe out 1,000 ants and break the chemical trail. A disaster for a top-down system. For the ants? It's nothing. The ants walking toward the break suddenly lose the signal. What do? Do they panic? Do they wait for new orders? No. Their programming simply reverts to rule number 1. Explore randomly. The system doesn't break, it just dissolves back into its base state. A distributed search party, already hunting for the next signal. This is the biological blueprint. A decentralized, emergent, and anti-fragile system for solving complex problems. We, on the other hand, build systems that do the opposite. We build brittle, top-down hierarchies that rely on a single, all-knowing leader. We create bottlenecks. We fear failure. When our signal breaks, our entire team stops and waits for a new plan from a manager who is already overwhelmed. We have been building our companies on a fallacy. Nature has been using a better framework for 150 million years. It's time we learn to copy it. Stop managing people. It's a radical idea, but it's the core of the biological blueprint. Start managing the environment instead. This is the entire strategic shift, moving from the central control fallacy to a framework of emergence. The ants don't have a manager yelling at them. They have an environment rich with signals, the pheromone trails, that tell them exactly what to do next. We can build the same system for our human teams. We can stop being brittle, top-down central planners. And start being environmental architects. We can extract the ants model into the 3-rule emergent framework, a system for replacing top-down directives with bottom-up intelligence. It works like this. Rule 1. Empower exploration. This is the human version of the ants' random search. In a traditional, top-down company, exploration is often punished. You are given a rigid task, and you are expected to execute it. But in a complex, uncertain project, the right path is almost always unknown. You cannot plan your way to a breakthrough. You have to find it. This rule means giving your teams clear goals, but not clear paths, instead of one massive, top-down project plan. You empower 10 small, autonomous teams to try 10 different, low-cost ways to solve the same problem. You are replacing the single, high-risk bet of a master plan with a portfolio of low-risk, high-information, parallel experiments. You are decentralizing the search. This is your search algorithm. But this only works if you have the second rule. Rule 2. Make work visible. This is the human pheromone trail. An ant's signal is useless if it's invisible. The same is true for your team. A breakthrough trapped in one person's inbox. A new piece of data siloed in one department. A small win that isn't shared. Heroes is not a signal. It is organizational noise. Your job as a leader is not to check in on people. Your job is to create a shared environment where these small wins and new data points are made public, instantly and effortlessly. This is not about adding more status update meetings. It is about building a shared digital ground truth. It's a company-wide dashboard. It's a truly shared Kanban board. It's a culture of public by default documentation. This is stigmergy. The work itself becomes the signal. When one of those 10 experiments from Rule 1 finds something that works, that success, that piece of data, must be deposited back into the shared environment for everyone else to smell. Which leads directly to the final rule. Rule 3. Amplify what works. This is the feedback loop. When an ant finds a strong, established pheromone trail, It stops its random exploration. It abandons its own weak, undiscovered path. And joins the proven superhighway. This is the hardest part for human teams. We get attached to our own projects. We defend our silos. We keep working on our own trail, even when the data shows another path is clearly superior. The rule must be: when a stronger signal appears in the environment, the team is culturally and logistically empowered to abandon weaker trails and swarm the proven one. This is how your organization self-optimizes. You don't need a manager to tell everyone to pivot. The environment, that visible, shared dashboard, shows that one trail is louder and more valuable than all the others. The team naturally flows to the highest point of value, just as the ants do. This is what creates anti-fragility. What happens when that superhighway project hits a dead end? The market changes. The technology fails. In a brittle, top-down system, this is a crisis. Everyone freezes, looking up the hierarchy, waiting for the master brain to issue a new plan. But in an emergent framework, the team knows exactly what to do. The pheromone trail has vanished. The signal is gone. Their programming instantly reverts to rule number 1: empowered exploration. The superhighway dissolves, and the team fluidly breaks apart into 10 parallel search parties once again. The system doesn't break. It doesn't even pause. It simply returns to its most creative, resilient, and adaptive state. So, let's review the journey. We started with our human obsession with central control. The fallacy that we need a master brain to solve complex problems. A belief that builds brittle, fragile, and inefficient systems. The ants showed us this is a lie. Their blueprint isn't a single, complicated genius. It is a set of 3 simple, local rules that create a decentralized, self-optimizing, and anti-fragile intelligence. This is the core of the superorganism. Translating 8 billion years of natural R&D into actionable frameworks for today. We call this the 3-rule emergent framework. And this is not just a theory. It is a new model for leadership. The question is no longer who is in charge, but is our environment guiding us? If you are a leader trying to build a more adaptive, resilient, and intelligent team, we run B2B workshops that train your leaders to stop being managers and start being environmental architects. This is applied swarm intelligence. Download the free Emergent Framework, 1-page PDF at our website. And learn how to build your own superorganism